Some boat engines earn a bad name because somebody skipped the impeller change for 6 seasons. A handful of them earned it the honest way. They were bad out of the crate, bad by design, bad in a way no owner could have maintained their way out of. Those are the ones worth talking about, because they are still out there, still being sold to somebody every spring, usually at a price that looks like a bargain right up until the compression gauge comes out. Here is the part that surprises people. The worst engines on this list were not the cheap ones. Several of them were the flagship, the newest technology in the catalog, the one with the magazine coverage and the launch event, the one that cost the most money on the transom that year. One of them helped put a Fortune 500 company into bankruptcy court, and the thing that makes an engine genuinely bad is almost never a loud, dramatic explosion. It is a quiet failure with no cheap fix at the end of it. A corroded passage you cannot see from the outside, a gear set nobody stocks, a block that cannot be rebuilt where it sits. I have had my hands inside more of these than I care to add up, and I have hauled more powerheads out of the back of a truck than most people will ever stand next to. What I care about is not whether an engine broke. Everything breaks. I care about what happens after it breaks. Whether the failure warns you first, whether a part exists, and whether the invoice is $400 or the price of a new motor. So we are going to go through the ones I would genuinely walk away from, and I will tell you exactly what fails and what the fix costs. Somewhere in the middle of this, I am going to get to an engine from one of the most respected names in the business, corroding from the inside where you cannot see it, and the remedy the manufacturer offered its own customers. That one still makes me put my coffee down. And at the very end, I am going to defend one engine that everybody puts on lists like this one, because I think the reputation is mostly wrong. Let's get into it. First, the standard I am judging by, because it is not the obvious one. A marine engine lives a life that would kill a truck motor. It swallows the water it is floating in, often salt water. It runs at 3/4 of its power for hours at a stretch, which is something your pickup never does even once. Then it sits for 5 months in a damp box, while everything inside it that can corrode gets on with corroding. So the question is never, did it break? The question I want you asking, item by item, is the repair path. What fails first? Does the engine warn you before it does, and when it does? Is there a part on a shelf at a price a normal person can pay, or does the road end at a quote for a whole new engine? Some of these motors were merely fragile. The truly bad ones took away your options. Start with the big one, the Evinrude and Johnson Ficht engines from the late 90s. The idea was legitimately good. A German company, Ficht, in Kirchseon, had developed a high-pressure direct injector for 2-stroke engines in the early 90s. OMC licensed the technology in 1995, put it on a production outboard in 1996, and bought a controlling interest in Ficht in 1998. On paper, it was the answer to everything. The cleanliness of a 4-stroke with the performance of a 2-stroke. And OMC needed exactly that, because the clean air deadlines were coming, and rather than tooling up for a complete shift to 4-stroke production, OMC decided to upgrade the 2-strokes it already had. Here is where it went wrong. And the sequence matters. The first design did not pass durability testing. Production started anyway, ahead of another round of emissions rules, and the company tried retrofitting the previous design to bring the motors up to the new standard. Those modifications were not carefully engineered. They caused significant engine failures, powerhead failures above all, and that generation of motors ended up recalled, Read that again slowly. The durability test told them. They built it anyway, then patched it in the field. What it cost is not in dispute. Beset by extensive warranty claims on the Ficht outboards, on top of financial problems it already had, OMC declared bankruptcy in December 2000, and the engine business and the Evinrude and Johnson names were bought by BRP in 2001. This was not some fringe operation. Johnson and Evinrude were about a third of world outboard sales. The parent company owned 13 boat-building companies, and it had factories in 12 American cities. Gone. Now the honest part, because you will meet the guy who has one. Some of them run beautifully. Owners will tell you theirs has hundreds of trouble-free hours on it, and I believe them. The pattern people who worked on them describe is that most of the trouble showed up inside the first 100 hours, and an engine passed that was probably a good one. Sources genuinely disagree on which years to avoid. Some say 98 through 2000, others insist things were sorted by 2001 and the post-BRP engines are a different animal. I take the conservative line. Treat anything with a Ficht badge as suspect until a dealer pulls the service history on the serial number and price it accordingly, which, in practice, is not much. Owners have been reporting resale values in the hundreds rather than the thousands for years now. Next, the early Mercury OptiMax 3-liter V6, roughly 2000 and 2001. Same era, same regulatory pressure, same idea, different company. OptiMax was Mercury's two-stroke direct injection line, in production from 1996 all the way to 2018, and let me be clear that later ones are perfectly good engines. It is a specific window that hurt people. The failure was the same organ, the powerhead. Go back and read what owners were writing at the time, and the numbers are brutal. A 2000 Model 225 that lasted 163 hours before it needed a new powerhead. A 2001 200 that went bad at 100 hours and got a factory powerhead from an owner who said the motor was never right out of the box. There was a recall on injectors, and one owner who pulled the warranty history on a pair of 2001 225s counted 36 warranty issues across both motors in the first 30 months. The dock nickname was OptiPops, and it did not come from nowhere. I will also tell you what I cannot verify. Owners refer to a class action over those motors, and I could not put my hands on the docket, so treat it as what people say happened rather than something I am asserting. The mechanics read I have heard more than once, and it fits what I have seen, is that the OptiMax built on the 2.5-liter block gave less trouble than the 3-liter. Rule of thumb, not gospel. Why it belongs on a worst ever list is the repair path, and it has not improved with time. When one of these lets go, it is not a bolt-on job. To put a number on the modern version of that cliff, an owner with a 2016 OptiMax Pro XS225 with 830 hours on it was quoted $12,500 for a new powerhead by one shop and $9,000 by the second. On a 20-year-old motor, there is no version of that conversation that ends well. Now the one that bothers me most, and it is not from a company anybody sneers at. The first-generation Yamaha F225 4-stroke, roughly 2000 to 2004. These motors ran well. That is what makes it so ugly. The problem was corrosion inside the exhaust, in a place you cannot see and would never think to check. A Consumer Protection Bureau at one of the big U.S. boat owners associations logged dozens of reports of serious corrosion in Yamaha outboards. Specifically, that first-generation F225, where after roughly 500 to 700 hours, the exhaust gases appear to corrode the exhaust tube and sometimes the oil pan, which sits in the same area. A New Jersey marine surveyor told them, I've seen the damage to 6 engines myself, plus another dozen he knew of locally. And here is what makes it a design problem rather than a maintenance problem. The failure is not outwardly visible, and what you notice instead is the engine losing power and starting to smoke. 500 hours. Think about what that actually is for a private boat. 50 outings a year at 4 hours a trip, and you are there in 2.5 seasons of genuinely enthusiastic use. Most owners take 8 or 10 years, so the corrosion arrives long after the warranty has expired, on an engine that has done nothing wrong, on a boat that has been flushed and serviced. The complaint that eventually got filed spells out the end of that road. One owner who had run her F-Series motor around 500 hours over 6 years described a rotten exhaust tuner and a hole in the exhaust housing. And the motor overheated and failed offshore near a lighthouse on the North Carolina coast. Another owner's repair invoice came to just over $3,000. Owners have reported the same pattern elsewhere in that family. The F150 comes up constantly, and one owner posted a pair of 2016 F-150s needing exhaust guide, midsection, and oil pan work at 750 hours on one and 850 on the other. Those are owner reports, not verified scope. Hold that one. I am coming back to it, because what happened next is the real story. Number 4, and we move inboard. The MerCruiser 470 family and its relatives, the 170, 190, 485, and 488, 3.7 liters, 4 cylinders, roughly 1976 into the late 80s. This engine is famous for one decision. The block was cast aluminium, designed by Mercury Marine itself, and it was mated to a cast iron cylinder head off the Ford 460 V8. Aluminium and iron expand at different rates when they get hot. That is not an opinion, it is thermodynamics, and the consequence shows up exactly where you would expect. The two metals moving at different rates during an overheat is a large part of why these got a reputation for head gasket trouble. Worse, the aluminium block is an open deck design. The cylinder walls are only anchored at the base, not at the top. So any overheat at all moves things around, and you can expect the head gasket to start leaking. Then, the details. The water pump is driven off the camshaft and its seals leak with age. And if you do not deal with that before coolant reaches the oil, the repair gets expensive. The original charging system has a habit of overheating and burning out. On the earlier ones, the cast iron exhaust manifolds crack and let water into the cylinders, number 4 especially. And if you ever do this job, use the MerCruiser head gasket, because a Ford 460 gasket meant for an iron head on an iron block will fail quickly. Now, in fairness, and this is the objection I get every time, I had one for 15 years, best little engine I ever owned. You internet guys have never even seen one. That is a fair hit, and it is often true. The people who actually own these mostly like them, and guys who worked on them for a living will tell you the known weak points can all be dealt with. But the reason it is on my list is the repair path again. It was the one MerCruiser that was not based on an automotive block. So when you need real internal parts, you are going to Mercury, not to the parts store. In 2026, on an engine last built in the 80s, that is a problem you cannot fix with enthusiasm. Number 5, and now we are burning diesel. The Detroit Diesel 8.2, the one everybody calls the fuel pincher. The name was earned. These things sip fuel, and owners who like them are genuinely fond of them for it. One owner ran a pair of the turbo version in a 25,000-pound boat and reports cruising at 8.5 knots on about 4 gallons an hour, with close to 2,000 hours on them when the boat sold. The engineering is where it comes apart. It is a four-stroke with the unit injectors Detroit was known for, but it is a parent-bore engine with an open block deck, which makes it prone to head gasket trouble. And the early engines had head bolts too small to generate proper sealing pressure. Owners who kept theirs alive did it with retrofits, bigger head bolts to stop the originals stretching and blowing gaskets, and a small hose tapped from the exhaust manifold to the heat exchanger to stop air pockets forming and cracking the manifolds. And a fair number of the 300 horsepower after-cooled version blew head gaskets in small sport fishing boats, where owners ran them hard. There is a pattern forming across this whole list, and we will name it later. The bit that puts it here rather than merely on a watch list is the ending. Mechanics who ran fleets of these say that once one overheated or needed a rebuild, it stayed a problem, and part support is close to non-existent. One owner who had two in a commercial boat put it about as plainly as it can be put. Techs were already warning him about long-term parts back in the early 90s. They truly were fuel efficient, and he would still steer clear. Worth knowing why. These were always meant as an interim four-stroke stopgap until the Series 60 arrived. You are buying a placeholder. 4 to go, including the one I think is unfairly hated. If this is the kind of thing you want more of, subscribe. The exhaust corrosion story a couple of items back is the reason I made this one at all, and I am going to finish it shortly. Before that, the shortest entry on the list, and the one I would run from hardest. The OMC Sea Drive. An outboard powerhead on a purpose-built bracket that hangs off the transom, with its own steering and its own tilt. I will keep this brief because the case against it is brief. The powerhead is a normal Evinrude, and normal Evinrude parts fit it. Everything else on it exists nowhere else on Earth. Owners describe hydraulic steering and trim systems made solely for that application, with parts that became big money and then became unobtainable. And here is the kicker. When it finally goes, you're looking at either a rebuild or major fiberglass work, because that integrated bracket will not support another engine. One owner reported dropping close to $10,000 over 2 seasons and then selling the boat for peanuts. There is no repair path. That is the whole review. Number 7 is a nuance case, and I want you to get this one right because it will save you money either way. The Caterpillar 3208, specifically at the top power ratings. The 3208 is a 636 cubic inch V8 that was built naturally aspirated and turbocharged from about 150 up to 435 horsepower. At the bottom of that range, it is a fine engine and thousands are still working. The problem is what happens as you climb. The old rule is you can push horsepower up to about the cubic inches, roughly 10.5 liters here, and 435 was the highest rating CAT sanctioned for marine use, which is why experienced owners say they would not go past 375. 2 specifics. These are non-sleeved engines, which is where the throwaway nickname came from, although I think that label gets misused. People who know these engines say throwaway was a design designation rather than a description, and they are rebuildable if there is enough material left in the block. One owner found receipts showing a catastrophic failure repaired by boring and sleeving the cylinders to take standard pistons. Fair enough. The second specific is the one that would keep me up at night, and it is a genuine design fault. On the 425 and 435 versions, there was no drain in the aftercooler, which sits on top, so condensation dripped onto the middle cylinders and corroded at least the valves. CAT had a program to sort it out afterwards, and not every engine got it. So on a boat with the high rating 3208s, That is not a rumor to dismiss. It is a specific thing to ask a cat specialist to verify was done. 8th, Chrysler outboards and the Force motors that came out of the same factory. I am not going to pretend these were sinister. They were built to a price, on purpose, for a market that wanted the whole package cheap. Chrysler Marine built outboards from 1965 until 1984, when the division was sold to U.S. Marine, the Bayliner people, and the engines were rebranded as Force. For a good while, the change was mostly paint, with the internals staying pure Chrysler. Later, Mercury components came in piece by piece: lower units, ignition, trim, and tilt, while the powerheads kept the older architecture until Brunswick discontinued Force in 1999. 2 honest points. First, the parts picture is better than the reputation suggests. The common service items like water pumps, carb kits, and ignition packs are still being made by the aftermarket, while the hard internal parts get harder to find every year. Second, the doc story about a certain 5-cylinder Force throwing its crank through the cowling. I have heard it for 20 years, and I cannot source the recall anybody claims went with it, so I am not going to repeat it as fact. What I will say is this: the youngest Force outboard is now 26 years old, and the oldest are pushing 40. A cheap engine built to a price, 4 decades on, is not a bargain. It is a hobby. Which brings me to the last one, and I am going to defend it, because I think this reputation is largely a ghost story: the OMC Cobra sterndrive. Everybody knows Cobras eat their gears. Here is what actually happened. Cobras do have that reputation. It is usually caused by a failed shift cable. It is easily prevented, and the drives are routinely maladjusted, which makes it worse. The chain of events is mechanically specific. A defective transom shift cable partially engaged the dog clutch, which shaved metal off the engagement surfaces, and a clutch dog stuck in partial engagement during a higher RPM shift broke gear teeth and wore fast. There was also a plainly bad detail in the routing. Cables binding at the plastic guide because the retaining screw got over-tightened even when the instructions were followed, fixed by backing that screw off one turn. OMC's first diagnosis was wrong, and I will give them credit for the second one. They initially thought the clutch dogs were disengaging from insufficient bite and increased the bite angle from 2 degrees to 5. That did not solve it, and the following year they re-diagnosed it as the shift cable. Then they did the thing that almost nobody remembers. They replaced any failed cable for free, and if a cable failure destroyed a gear set, they replaced the gear set too, on a part that was running close to $1,000 by the late 90s, labor on top. And that extended coverage ran until early 1994. The trade remembered the gear failures and forgot, or never heard about, the cable fix. So it is not a great drive, and parts and mechanics are genuinely thin on the ground now. But the specific thing everyone repeats about it was a cable, and it was addressed. That matters because in a minute I am going to show you a case where it was not. Now the part I have been building toward all the way through. Go back to that Yamaha exhaust corrosion. Not to the corrosion, to what was offered to the people who owned the engines. Because that is the moment where you can see exactly what you are, in the eyes of the company that sold you a motor. You bought a 4-stroke outboard from the most respected brand in the business, largely because you were told these things last. The exhaust components corrode from inside on a clock you cannot see, on an engine you have flushed and serviced, and it typically shows up somewhere north of 500 hours, which for most private owners is years after the warranty ended and years before they were done with the motor. You cannot inspect for it. The first symptom is lost power and smoke, or an overheat offshore. And the remedy? A kit. You pay for it. Owners describe being told the repair kit was around $700 in parts, and that nothing could be done because the motor was out of warranty. Another owner had the updated exhaust fitted to one engine and did the second one that winter, and said the plain reason was not even the corrosion. It was that he could not sell the boat with it hanging over him. That is the tell, right there. The fix existed. The engineering was understood. The revised parts were sitting on a shelf with a part number. What was on offer was the privilege of buying them. Then the arithmetic gets colder. When owners took it to court, the class members said corrosion in the exhaust components ultimately causes the motor to fail prematurely if it is left unrepaired. And the case went nowhere, not because a judge found the corrosion wasn't happening, but on plumbing. The breach of contract claims turned on whether there was a direct financial relationship with the manufacturer and whether the suit was filed in time. Neither was satisfied, and for second-hand buyers, there was effectively no privity at all. Read what that means for you. You bought the boat used from a private seller, like most people do, so you never had a relationship with the company that built the engine. And the defect took long enough to appear that by the time you could see it, your clock had run out. That is not a conspiracy. Nobody sat in a room and decided to hurt you. It is just that a design flaw with a long fuse costs the manufacturer almost nothing and costs you $3,000, and every incentive in the arrangement is happy with that split. The lawyers on one of these matters said at the time they were fielding 8 to 10 calls a week from people with the same problem. So when you hear maintenance-free or sealed, or a warranty measured in years while the failure is measured in hours, ask whose clock that is. It is not yours. You know the shape of it now, and it will not catch you the same way twice. Something worth sitting with for a second, though. Every engine on this list was designed by people who were not stupid. The FICHT injector was a genuinely clever piece of engineering that eventually became a good motor. The technology was re-engineered into E-Tech after BRP bought the brands. The 8.2 really did sip fuel. The aluminium block in the 470 was a serious attempt to build a light, powerful four-cylinder when nothing on the shelf did that job. They failed at the seams, where a deadline met a test result, where the last 20% of horsepower got wrung out of a block that had already given what it had, where the accountant's version of a fix met the engineer's version. And the reason that is worth knowing is that judgment is the skill this whole thing rewards, not brand loyalty, judgment. Anybody can learn a list of engines to avoid. What is actually useful is being able to look at any machine and ask where it was compromised, who ate the compromise, and whether there is a part on a shelf when it lets go. That skill did not come from manufacturers. It came sideways, hand to hand. The old hands who figured out the Cobra needed the cable checked and the guide screw backed off and told each other before anybody wrote it down. That is still how most of it travels. So here is the procedure, and I would use it on any used boat, not just these engines. 1. Get the serial numbers off the engines before you get emotionally involved, and have a dealer for that brand pull the factory history. Warranty claims, powerhead, replacements, recall, and update work. The computer knows, and the seller may not. 2. Compression on every cylinder, and you want them within about 10% of each other. Above roughly 1,500 hours, that is non-negotiable. And once you are past 2,500, treat a repower as a matter of when rather than if. 3. Inspect the exhaust, because that is where the money hides. On an older raw water-cooled inboard or sterndrive, budget for it. Risers and manifolds in saltwater are commonly considered 3 to 5 year items, and a corroded set runs somewhere in the $800 to $2,500 range in parts. On the outboards we talked about, ask specifically what was done to the exhaust components and get paperwork. And a real safety note while we are here, a leaking riser can put water into a cylinder, and an exhaust leak inside an engine box is a carbon monoxide problem, not just a repair bill. Do not let anybody talk you into running one more season. 4. Price the worst case, not the likely case, before you make an offer. Marine labor at a certified dealer commonly runs in the range of $125 to $175 an hour. A full outboard repower with rigging is quoted at figures like $40,000 to $50,000 for twin 225s in 2026, and a straight single-engine swap runs 8 to 16 hours of shop time depending on the boat. Get the real numbers for your engine in your area. 5. Then the decision, and this is the part to actually write down. If the worst credible repair costs more than about 40% of what the whole boat is worth, and there is no parts path, no shelf, no specialist, no aftermarket, walk away. Not because it will definitely fail, because if it does, you are done. And you will be the one standing on the ramp doing this arithmetic in a much worse mood. Run that on your own numbers, and you get something better than a list of engines to avoid. You get the bill that never shows up. No tow, no winter of phone calls with a marina, no 5-figure quote on a boat worth $11,000. Just a boring, uneventful season where the thing starts every time and you never think about it once. Now, I know exactly who is going to disagree with me, and I want to hear it. The guys with 2,000 hours on a Ficht that has never missed a beat. The Force owner whose motor outlasted 3 of his friends' fancier engines. The 470 crowd, who are the most loyal owners in this entire hobby. If you think I have been unfair to one of these, come and argue, but bring the numbers. Hours, years, salt, or fresh, what you have replaced and what it cost. That is the stuff that is actually worth reading, and other people making this exact decision this month will read it. I read the replies on these. Everyone, and I usually learn something I did not know when I started, which is most of why I keep doing it. There is one thread here I deliberately did not pull, by the way. The failures on this list keep landing at the same place. The last chunk of horsepower squeezed out of a block that had already given everything it had. Same story on the high-rating 3208, the 300-horse 8.2, the 3-liter OptiMax. I have been chewing on how you spot that from the outside before you buy, and I do not have it cleanly worked out yet. When I do, it will be here. If you want to be around for it, subscribe. Until then, check your risers, get the serial numbers, and price the worst case before you fall in love with the boat.